Welcome to a presentation on BCI Analyst, improving the life cycle cost of a pumping system. The first priority of every water pumping system is to meet the water demand of the community being served. In order to meet that demand, pumping systems need to operate at a range of pressures and flows. What many don't realize, however, is that the pump is not designed to operate at a range, but at one specific point of pressure and flow called the best efficient point. At this point, radial forces are minimized, and flow is the smoothest. Pump performance quickly deteriorates as the pump moves away from its best efficient point. To overcome this problem, manufacturers build pumps that are incredibly strong. These pumps are so durable that if they could operate at their best efficient point all the time, they might never break down. Unfortunately, most pumps will rarely operate at their best efficient point. To understand why, we need to talk about pump performance curves. These specifications, which are provided by manufacturers, include the pressure and efficiency curves, which intersect at the best efficient point. The problem is that these curves are a moving target. Although they may look pretty straightforward, that changes as soon as the speed of the pump changes. While the flow change caused by speed is linear, the pressure change is exponential. With the curve's two variables changing according to different rules, tracking the curves becomes a serious math challenge. On top of that, pump curves change over time due to wear in ways that can't be predicted and will be unique to each pump, even within the same system. That makes the manufacturer's curves unusable. With no way of knowing where the actual pump curve or best efficient point are at any given time, it's no surprise that most pumps only ever hit their best efficient point by accident. In fact, the average pump operates at an appalling 40% efficiency, with 1 in 10 pumps operating below 10% efficiency. Operating at these levels causes excessive wear and damage to the pump, resulting in more frequent repeat and random failures. Pump failure can be predicted by the reliability curve, which shows the relationship between pump failure and operating away from the best efficient point. The best efficient point is at the top of this curve. Unlike the even slope of the efficiency curve, the reliability curve is a sharp peak. While you lose efficiency at a consistent rate when operation moves away from the best efficient point, the reliability drops off quickly and dramatically. When pumps run 20% to the left or 10% to the right of the best efficient point, they experience rising temperatures, low flow cavitation, bearing issues, and reduced impeller life, as well as suction and discharge recirculation, which can lead to seal failure and pump downtime. These huge costs of operating away from the best efficient point are universally accepted as an inevitable sacrifice to fulfill that top priority: meeting demand. By combining all of the information on pump performance that we just covered with live process data and even more math, BCI Analyst makes it possible to apply the reliability curve and best efficient point to daily operations so you can finally meet demand while increasing efficiency and decreasing failures. By analyzing process data like speed, flow, pressure, and energy, BCI Analyst is able to generate pump performance, efficiency, and reliability curves for every pump, not based on manufacturer specifications, but on real live input from your pumps. With that data, we can track changing curves over time to monitor the reliability, flow loss, and efficiency, not just of the whole system, but of each individual pump as it wears. With that information, in real time, we determine the most efficient, reliable, and therefore cost-effective way to operate, and then either send it to operators as recommendations or automatically make adjustments. BCI Analyst enables you to take chunks out of both of the biggest contributors to life cycle cost: Increasing reliability decreases maintenance costs, while higher pump efficiency decreases energy costs. And, best of all, Analyst does all the math. If you'd like to find out how BCI Analyst can help you save up to 25% on maintenance costs and 10% on energy costs, contact us today at bcianalystinfo@bcitech.com.